Hello everyone, humanHardDrive. Today on Electronics 101 we're going to be talking about voltage regulators. Voltage regulators are a series of components, or in this case what we're going to be talking about today, a couple ICs, which take some input, that's a second T for some reason, input voltage, and make it into an output voltage. Most importantly, of course, that when taking the input voltage to the output voltage, it makes it stable. It regulates it, because it's a voltage regulator. And it also does a couple other things like step down or step up, meaning it will take the input voltage and make it lower or higher, depending on the IC. So we're going to be talking about two kinds of voltage regulators today, starting with, of course, the linear voltage regulator. There we go. Linear voltage regulator, probably one of the most common kinds of regulators out there. Most common of which is the 7805 voltage regulator. And it works something like this. You have 3 pins, an input voltage. Typically, you've got 3 pins. You've got an input voltage, you've got an output voltage, and then you've got a ground pin. And typically these are connected, you've got the input connected to ground and the output connected to ground via a capacitor, generally a, what's it called? It's a polarized capacitor. That's the word, P, polarized. Probably about 1 microfarad, somewhere within that window, 1 microfarad. That is not a mu. Let's try that again. There we go. That's a mu. There we go. 1 microfarad. Now, linear voltage regulators will work something like this, and this is specific. I should probably draw ground. There we go. These specifications are kind of specific to the 7805, but the basics of what I'm talking about are true for most linear voltage regulators. You have input, some input voltage, which works within some window. In the 7805 case, it is anywhere from 7 to 12 volts. And then you have the output, which is, of course, one value, and in this case, it's 5 volts. And, of course, this is stable. Again, it's a regulator. It makes it stable. Well, that's also what the decoupling capacitors do, but stable. So, the key is if you put in 7 volts or you put in 12 volts, you get 5 volts out. And that's always true because it's a regulator. So, this is good if you have, say, an Arduino, really any microcontroller you want to power that requires 5 volts, and you only have a 9-volt battery lying around. You can hook it up to a 7805, take that 9-volt input, step it down to a 5-volt output, and that 5 volts will be stable. Now, those 5 volts will be stable until a point. And that point comes at the dropout voltage. What's the dropout voltage? Well, in the 7805 case, that's a colon. That's at 2 volts above the output voltage. What does that mean? There's a reason 7 is lowest, because 5 plus 2 is 7, so that's the lowest possible value you can get. If you drop below the dropout voltage, if you drop below 7 volts, the output will no longer be a stable 5 volts. It will drop to 4.9, then 4.8, then 4.6, then 4 volts, and it'll tumble erratically, because it's not stable anymore. You've gone beneath its dropout voltage, and it's the voltage regulator starting, its function is breaking down. So it doesn't work anymore. So you have to keep it within that 7 to 12 volt range, preferably a good bit above 7 volts so that you're not walking the line. So yeah, if you're using a 9-volt battery, you're sitting comfortably within, right smack dab in the middle of that range, and you've got 2 volts until you have to start to worry. So that's good. Now, this is the 7805. This is one type of linear voltage regulator. Specifically, this is a fixed output linear voltage regulator, because the output is always 5 volts. There is another called a, I'll just move on to a new page, called an adjustable linear voltage regulator. There we go. That's a decent line. Linear voltage regulator is, let's see here, linear voltage regulator, I'm trying to remember the chip number off the top of my head, is in this case, well, one linear voltage regulator is an LM317. So I'll just call it a 317. And it typically also has three inputs. You have, or 3 pins. You've got the input, you've got the output, and then you've got this pin down here, which isn't technically ground, but it's still kind of connected to ground, and this is the adjust pin. And the way you tweak the output voltage is through 2 resistors. One resistor you have attached between the output and the adjustment pin. This is sort of like a feedback. Well, it is actually a feedback. This one is typically 240 ohms. And then you've got a potentiometer down here, which connects to ground. And this is generally around 5 kilo ohms. This is R1, this is R2, and that will become apparent in just a minute. The input and output, still a good idea to connect those to ground via capacitors, but I'm not drawing them just for simplicity's sake. Okay, so you've got these 2 resistors. So how do you use that to calculate V out? Well, in this case, V out is Vref times 1 plus R2 over R1. And RF in this case is generally 1.25 volts. So with this, you can calculate what your output will be given the input voltage. And I think for the 317, you can output anywhere from 5 to 31 volts. I might be wrong. That sounds a little weird, but I think that's right. It sounds right. We'll just assume it's right. Now, like the... Ooh, another dot. Like the 7805, the non-adjustable linear voltage regulator, the fixed linear voltage regulator, this does have a dropout in that the dropout, or the... It's not called a dropout technically, but the input must be greater than 1.5 volts plus the output. So you have to keep that in mind. It always has to be 1.5 volts greater, otherwise it doesn't, the feedback doesn't work, and, well, you don't get the output you want. So keep that in mind when you're using a linear voltage regulator. This is good if you have a voltage system which is weird, or you want to adjust on the fly, or this is also actually used in battery charger circuits, because the input voltage and the input voltage will stay the same, but the output voltage will change because as you charge the battery, it will output more voltage, and that will change the ratio, and that's actually where the breakdown is helpful for you, but that's another story. Just keep in mind that this is adjustable, whereas the 7805 is fixed. So those are the 2 different kinds of linear voltage regulators. Okay, let's talk about the drawback to this. Scroll back up. Let's say I've got a 7805, and I'm putting in the full 12 volts. I'm getting 5 volts out. Where's that 7 volts going? Where is the V out? And I do that backwards. Where's the V in minus the V out going? Where? This is very crucial, and it speaks to the greatest inefficiency of these. Linear regulators are really great if you're using voltages that are close to the voltage you want to step down to, like the 9 volt to 5 volt example, or in situations where you're not drawing that much current, like with a microcontroller. But with the 12 volt, say you're trying to drive a motor controller, the 7805 really, it becomes apparent why it's inefficient. I showed this formula, I think, in one of the earlier videos. Power equals VI squared. Power is equivalent to voltage times current squared. And with electronics, most of the time, power means heat. That's where that voltage is going. 7805s, 317s, linear voltage regulators in general will get hot. Very hot. If you've ever seen the package, the actual chip itself, you'll know it has a large metal backing to it. That's where you attach a heatsink to keep this thing running cool. So this thing will run hot because it's taking the voltage you're stepping down, and that excess voltage, it's just turning into heat. So again, they're good if you want to, if you've got the 9 volt to 5 volt scenario and they're very close together, or you're not drawing that much current. But the second you need more voltage, the second you're using a higher voltage supply, or you need to draw more current, that's where this stops working. So that is where these come in, the switched mode voltage regulator. Really should be an acronym for these. SMVR. Yeah, no, it doesn't work. SMVR. Oh, actually, they're also called switch mode power supplies, SMPS, which sounds better, but okay, switch mode voltage regulator, or switch mode power supply. These are quite common. If you have a desktop computer lying around, maybe you're watching this on a desktop computer, or you've taken apart a desktop computer at some time, you may know it has a large metal box in it. That's an ATX power supply. That's a switched mode power supply. And the way they work is you have some voltage connected to a switch, which is then connected to some circuitry stuff. It's not really that important how it works right now. And then that gives you an output. But the key is this switch right here. What's driving this switch is generally a high-frequency clock in the order of tens of in the kilohertz order. So it's oscillating very quickly, and by adjusting how it oscillates, you can, and how that oscillation affects the circuitry we've got here, you can affect the output. The other cool thing, well, there are a lot of cool things about this, but it's much more efficient because it's not just burning that power away. It's rapidly connecting the bits. Yeah, it's rapidly connecting the bits. It's rapidly connecting the power you want to regulate to the regulation circuitry. So there's no heat to speak of. So it's much more efficient. And I just forgot the point. It's much more efficient. It's kind of cool. Third one, it'll come to. Oh, that's it. This works in both directions. You can step up or step down. So you can step up, or you can step down. This is called boost, and this is called buck. Whereas with the linear voltage regulators, you can only step down, which isn't as useful. So if you've ever heard of the Minty Boost, or you've built the Minty Boost, it takes 2 AA batteries, which only produce 3 volts, and steps it up to 5 volts, enough to power your phone or a USB-enabled device. Real useful. And it's able to step down in your ATX power supply. It's able to step down the 120 volts coming in from your wall after it's been rectified, and step it down to, I think, 12 volts, 5 volts, and 3.3 volt levels. So it's really useful. And again, it's very power efficient because almost nothing goes out to heat. Now, one of the sort of most basic kinds of switch mode power voltage regulators is the LT1. Wow, that's not gonna look good. LT1 Zero. That's an L. That's a lot of letters that look very similar. This is I think it's an 8-dip. It's an 8-pin package, so it's pretty small. And this is a step up and step down switch mode voltage regulator. You can buy them in solely step up or step down. This one is both. Generally, they're a lot more complicated circuit-wise because you have to throw in a couple inductors or a cap, because they work by flowing the voltage and the power through these ideal components through inductors and capacitors, which can store them and build them up or step them down. So generally these require a lot more components, but they are much more power efficient. Now the LT1 Zero is just one kind of switch mode voltage regulator. And because there's so many different kinds, it's really kind of hard to show you a typical circuit. So I'm going to show you what a simple step-up mode for the LT1 Zero. So you've got your thing here. This is going to be tricky to draw. You've got your current limiter. You've got your voltage in. This is out of their data sheet. You've got the switch, number 1. You've got feedback, and then you've got the second switch, and then you've got ground. Yeah, butter. That looks. There we go. Let's try this again. That's a little better. Wow, it is really hard to draw today. There we go. And so you've got VN. There we go, VN. That connects via some resistor here. This is R3 according to the data sheet. And this connects to VN. And then through the inductor I mentioned. Oh yeah, and I forgot that they also rely on diodes, because then this feeds into switch number 1. This feeds into a diode, which is connected to the output. Feedback is connected through a resistor, a voltage divider. This isn't necessary, and then I'm going to scroll down a bit. There we go. This connects to this switch, which connects to the ground. There we go. And pull this back up. Come on, scroll. There we go. And then this connects via a cap. There we go. Okay. So, this is L1, D1, R2, R1, and C1. Okay. That is probably one of the most poorly drawn schematics I've ever done, and I apologize. You can find this in the data sheet, I assure you. So the way this works is very complicated. Inside here is switching circuitry, which will connect and disconnect various aspects of this. You can see here's switch 1, and here's switch 2. So through switch 1, remember, this is a step up. So voltage in is going to be built up in the inductor, and then because switch 1 is closed, and then switch 1 opens, it'll let it through, and switch 2 closes, and you get stuff to build up in the capacitor, and it switches back and forth. And when it does this, you get a higher output voltage than you had input voltage, and that's how a switch mode power regulator works, by switching between two aspects of the circuitry to either step up, boost, or step down, buck the voltage. So this one is a lot more complicated, but remember, it's much more power efficient, and you get the step up and step down. It also requires a lot more external circuitry. But remember, this is more power efficient. So you can use this if you have, say, a 12-volt power supply, something you wouldn't want to use with the 7805, and you need it to power something that runs off 5 volts. You can use this. It's much better. You'll also get a longer battery life off that 12-volt battery than you would off the 7805. The 7805, remember, because everything goes out to heat, or the voltage difference goes out to heat, your battery life's not as good. So, again, there are pros and cons to both systems. Price, efficiency, extra components, battery life. It goes back and forth. But it all depends on what you want to do. So 9-volt battery to, say, an Arduino, 7805. Perfect. Adjustable voltage regulator, kind of different situations. You're probably going to stick with 7805 no matter what. This is really only useful if you want to build like a battery charger, which you can, I think they have in their data sheet. It's a really simple circuit to build. Switch mode voltage regulator. Really useful, but also really complicated. A little more expensive, but higher efficiency. So use this if you want. If you've got a bigger voltage supply, you need to step down, or you've got a smaller voltage supply and you want to step it up. Works both ways. So all depends on your situation. So there you have it. This was Voltage Regulators. I'm humanHardDrive. Thanks for watching.